question number 20 is kind of like an algebra question, I guess. It says like let a, m, and c be non-negative integers such that a plus m plus c equals 10. And we want to find what is the maximum value of a times m times c plus a times m plus m times c plus c times a. So for like these kinds of questions, this is like a very classic kind of like optimization question where you're given some like kind of condition and you want to like find what is like the maximum possible value of some expression, right? So the idea for this is like for this kind of question, it's really like based on like experience. So one way like you can do this is you can look at the expression a times m times c. So this is the expression you have. So like the idea is like this is very close to if you take the expression like a plus 1, so kind of like ignore these, right? So like let's do this in a different color. Like if you had a plus 1 times m plus 1 times c plus 1, right? So like if you had like this expression, like this red expression, just ignore the black expression on the top. So if you had this red expression and you were to like expand it out, like what would you get? So like if you were to multiply this out, like a plus 1 times m plus 1 is a times m plus a plus m plus 1, then times c plus 1. And then if you were like expand this out, you would get like a times m times c plus a times c plus m times c plus 1 plus a times m plus a plus m plus 1. Or actually this is supposed to say plus c. So like if you were to like expand out this entire expression, this is like the thing you would get. So if you were to like just rearranging it, right? You can write this as a times m times c plus a times m plus m times c plus c times a plus m plus c plus 1. So like that's just like if we take this original expression, like this a plus 1 times m plus 1 times c plus 1, and we were like to do the distributive property a bunch of times and like carefully expand it and like simplify, we would get like it equals this thing here. And the reason like we might like be motivated to try that is because like we see that this like blue thing here, right? A times m times c plus a times m plus m times c plus c times a is like exactly like the expression that we want here. So like that might make us feel like we're on the right track, right? So then we can kind of like notice that like we know a plus m plus c equals 10. Like the original problem said a plus m plus c equals 10. So that tells us that like this expression here equals 10. So like plus 1, this equals 11. So if we were to subtract 11 on both sides, like we can kind of say that a times m times c plus a times m plus m times c plus c times a, I can say this is equal to, and then remember the expression we started with, a plus 1 times m plus 1 times c plus 1. And then I can just subtract 11. So I can kind of like have this identity sort of. And we basically want to find the largest possible value of like this expression now. So in order to maximize the expression in blue, that's equivalent to like finding the maximum possible value of like a plus 1 times m plus 1 times c plus 1, subject to the condition that a plus m plus c equals 10. Remember, that's like in the problem condition. So what I can do now, just to like make like life simpler, I guess, if we let like x equal a plus 1, we let y equal m plus 1, and we let like z equal like c plus 1, right? I can do that. Then I can say like this expression here, that's equal to x times y times z. And then here you have minus 11. And if I were to like simplify this a plus m plus c equals 10, so from here I can get a equals x minus 1, like m equals y minus 1, and c equals z minus 1. So if I were to plug these into the blue equation, I would have like x minus 1 plus y minus 1 plus z minus 1 equals 10. So I would get x plus y plus z equals 13. So essentially now we can like translate our statement, rephrase our problem as saying, suppose we have x, y, and z that are integers, so that x plus y plus z equals 13, and we want to find the maximum possible value of x, y, z minus 11. So this is like a much easier problem to like handle, I guess. And to do this, like you kind of have to have like this like general knowledge, right? So like if you have like this mainly comes from experience in problem solving. Like if you have like x plus y plus z equals some like fixed value, right? In this case, it's equal to 13. Like if you want to like make the product as large as possible, like you want to make x, y, and z like as close together as possible. Like this is kind of like a like math thing that you should know, right? Like to make it more clear, right? If we let x, y, and z be like as spread out as possible, right? Like if we had like x equals 1, y equals 1, z equals like 11 or something, then clearly x times y times z is like 1 times 1 times 11, which is 11. But if you made x, y, and z as close as possible, like if you made x like 3, y 4, and z like 6 or something, like clearly this in this case x, y, and z are closer. 3 times 4 times 6 is like 72, which is like significantly larger. So like just know that like it's a useful fact to know that like in general, if you want to maximize a product and you're given like a condition like this, then you want like the variables to be as close as possible together. And this like generalizes to more than 3 variables. Like you have 4 variables, 5 variables, and so on. Like the general rule is that you want the variables to be as close as possible in order to maximize the product. So yeah, so like knowing that, if you want to maximize the product and we know x plus y plus z is 13, the way to make x, y, and z as close as possible is to make like x equal to 4, y equal to 4, and z equal to 5. So like in this case, they're as like close as possible together. So then like x times y times z is 4 times 4 times 5, which is 80. So we want x, y, z minus 11. So then our final answer would be like 80 minus 11, which is equal to like 69. Yeah, so that would, going back to our answer choices, that would give us like choice C. Yeah, that would be the correct answer.